Great. Hello, good afternoon. I am Belen Fernandez. I want to thank the organization committee for the invitation to come here. And briefly, I want to present where I work. I work in the IRTA, the Institute of Research and Technology, agro-food industry. We are in Catalonia, and we research basically. We work together with the farming, fishing, and agro industries. So we know what all the waste, what are produced in all these industries. We know we are a public industry, but we are also a research center and a technological center because we also have a lot of activities of transfer, innovation, and development of technologies, mainly oriented to have all these developments to the market, to bring them to the market. We are distributed in Catalonia in different centers and lands, and the best part of the IRTA is that in these centers we also have farms and agricultural plots where we can apply some of the byproducts that we are obtaining. So some of these farms that we have are focused on the project that I'm going to show you today. Before we start with the project, I'm going to tell you about the group where I work. IRTA is distributing different working areas as production, the animal production, vegetable production, and the production into food. In my group, it's called a Program of Sustainability in Ecosystems, and we work with all the waste generated in these activities to transform them into biogas or, for example, fertilizers, with the idea of improving the sustainability of the agro-food industry. The working lines, the research lines that we are working nowadays are related to the biotechnology, bioprocesses to transform these products into added value products. Because we work a lot with the biological products based, we are able to detect all the fungi and all the bacteria that are necessary for these processes. We can quantify them and also identify them in order to know which are the ones that are really participating in these activities. Of course, that we need to channel this material, the waste, but also the environmental materials like the soil, water, because they are part of the products that we are trying to recuperate. And also in the cycle, to identify if the new processes that we are implementing are sustainable from the indicators, the indexes like for the footprint, for example, CO2 footprint. The project is called Bioenergy, and we are implementing it in a farm that IRTA has for the production of milk, cow milk. And in this case, in some of the actions that we are implementing, we are going to install a biogas plant and also to install a system, a composting system of digestate that is going to be generated in this biogas plant. This project is going to be implemented in this farm. It's called EDAM in Girona, and the agricultural land part, the demonstration of what we are, how is working these products when we apply to the plots. You can see the results in Masvalia is the name of those plots that we're doing, applying these products obtained from these processes. As I was saying, the valorization of the digestate and the production of biogas and the compost is within a block of actions that we are implementing in this farm, with the idea that we want to install and implement methodologies available to improve the sustainability and the circular economy in the activity of the production of milk. Apart from the biogas production, we are also installing other systems like solar panels, also to cover the farm energy demand, also for the cows' conditions, and to take all the food close by the farm, and also for the precision in order to reduce or actually improve the sustainability or avoid the loss of some of these ingredients. Lastly, as I was telling you before, Based on this life cycle that I was telling you, we could evaluate, assess what's the result of all these techniques, and we're going to put that in a digital platform that you could download all this data. The project started last year, and this year we are starting to implement many of these methodologies. Nowadays, here you can see in this image the picture of Google Maps in the farm. We can see that the production of milk is around 1 million, a little bit more than 1 million of kilograms of milk. But we sell the milk, so it's in a real situation of milk production. The farm right now, we have like 110 milking cows, but we also have another animals for reproduction of meat production. And I must say that the whole farm is between agriculture plots and forests, but all of them are vulnerable of nitrates. So we have some restrictions when applying the dejections to apply in the same farm. But in this farm, it's going to have enough surface, agricultural surface, so we don't have a problem about the kilograms of nitrogen generated. So we don't have the problem in the interest of these technologies. It's more like a solution for a problem of directive access, but also to prove that the technologies are feasible and economically they are possible. For all these aspects, we have here a list of all the consumptions, not only about the ingredients, but also water and fossil fuels, and also we also have the waste that is being generated here, and this is the amounts that you can find. There is some fractions of liquid, solids within the same facilities, and also we have all this data available about the solid and liquid manure, but also the other waste that are being generated, like for example the waste coming from the feed, and also the wastewater that is being produced in the milking room, and this is being generated every day. This wastewater. As I was telling you, some of the implementations had been done, mainly related to the animal feed, and from the point of view of the dejections management, you could also see we have been improving the management of the liquid slurries and manure that is being generated in the plant. Nowadays, we are making a small compost of the manure, but we're going to improve that with the next actions. With the idea of improving the impact and the sustainability of the plant, we're going to do 3 big actions. One of them is to cover the pools. You know that all the farms have pools and wells that they have to accumulate all the materials before applying that to the plots. So we're going to cover these pools with different techniques that are available, and we're going to improve the compost production. The main goal here is to improve the quality and to obtain a product that is enough sanitized and stabilized to be used as a material for the livestock. For example, like straw and sawdust in these livestock pens. And here you can see the locations of all the facilities where the manures and the pools and the final pools are. And here you can see also the sum up of the systems that we're going to implement in the purification of the pools. Previously, we have been doing the measurements of the GHG and the ammoniac, and during the year before, and the installation of all these systems covering all these, like flexible systems or natural ones that are now we're assessing this system, but they are installed in a year. I'm going to tell you how much they have been reduced, the emissions I'm talking about. I will give you the results next year. From an anaerobic digestion point of view, we're going to transform one of the pools that are already existing in the plant into a digester. We're going to cover it, and we're going to make a minimal agitation, and we're going to have the digester partly underground. The biogas that is going to be produced is going to be for self-consumption, to produce the heating and hot water that we need to use to clean and sanitize the milking room, and also some part for the cleaning of the pens and the facilities. The surplus of heating, we're going to use it to keep a minimal temperature that it goes around 20 degrees, mainly during the winter time, because in this area we can go down to 8 or 9 degrees in January or February.
Previously, during 2024 and 2025, we characterized through the different waste being generated at the farm. Not only the liquid fraction and the solid fraction, but also all the water waste. So we have an idea of how much biogas we are going to generate. You can see the biomethanization typical trials graphs, but in this operation, we actually calculate the operation, the psychrophile regime in order to know the demand in the farm, by the farm. Right now, we are processing it, so finally, during 2026, the process is finished, completed, and we can actually start operation. Regarding the compost part, right now, a small part of a solid fraction of the manure in the farm, is being actually is being processed, and we are going to do it in a single area so that a forced aeration system is being built to cover, the batteries so that, they can actually the cells. And that implies a big amount of gas oil consumption. So by centralizing the compost generation with a forced aeration, we are going to produce a consumption of this diesel in this case, but also we are going to obtain good material to return it to the as animals' beds. When this compost is used as beds, and after being used for some time, then the material is being used for as an application for crops. After these actuations and the installation of biogas in the ponds, etc., pools, the greenhouse gases will be reduced as well as ammonia content. And in this device displays, you can see the estimations, and in the best cases, 25% regarding the ammonia reduction. When it comes to compost, we based on real amounts weekly, we generate weekly, we actually make some calculations to know which type of system we have to apply. You can see here, the trial, some of the images of the trial, and to assure the sanitation, we need this aeration and the tossing of this material for some 90 days. We expect to reduce the times with the forced aeration. These are the characteristics of materials, and you can see that composted material is being reduced. Not only is about compost with manure, but also the concentrated digestate fraction. So to achieve a different mixture that it can be found at the farm. And that's why we are, trying different mixtures with different materials. The one you can see in the corner represent, these mixtures of digestate plus manure in order to design the forced aeration new installation. To summarize, after the implementations of this year and the next year, implementations, we are going to actually remove some of the black problems, the black problems, generating, contamination, to reduce the environmental impact, to stop using fossil fuels by using this biogas with this technique, improving or the replacement of the external materials such as dash. And last but not least, an improvement of emissions and pool. So this is my contact details in case you want to make a question. Also, after the plant is working, the idea is to use it in order to apply a different type of technologies so we can make some progress.